Naveen sir, am I audible? Geeta ma'am?
Yes, sir. I'm here. Am
Ma'am?
I audible?
Geeta ma'am?
Am I audible, sir?
Yes, ma'am. Am I audible, ma'am?
Yeah, yeah, you are.
Yes. Shall we start, ma'am?
Yeah.
Yeah, very good afternoon to all of you. That was a thought-provoking session yesterday. And today, I would like to welcome our speaker, Ms. V. Geeta, for the third day workshop. Now I hand over the session to Ms. V. Geeta. Ma'am, over to you.
Thank you, Vishwanathan. Very good afternoon, all of you. It's really, I'm glad to connect with you on the third day of our workshop. And what are we going to do today? We will be discussing two major topics in R. One is how to work with files. And then next, we will be learning how to plot graphs using R functionalities. And before that, I would like to give you a quick recap on what we did yesterday. Yesterday, we discussed how to work with various data structures supported by R, namely vectors, list, data frames, factors, all those things. Now let's move on to the today's topic, handling files. I'm sharing my screen. Here you go. So definitely when we deal with large amount of data, all our data will be residing in files. So we should know how to interact with files through our environment. Interaction with file is nothing more reading the existing data and writing our data into the file. That's said to be file handling. So R is providing various predefined functions that will help us to work with any types of files. Basically, how comma separated files, that is CSV, Excel file, XML, JSON, and even other type of binary files also we can work with. And or has even the functionalities included on interacting with databases as well. So we will be looking at some of the important things as a part of our session today. First, let us start with how to read and write data inside CSV file. CSV is nothing more comma separated file. It is a plain text file. We will be able to read the content of this file. Uh, all the data will be separated by comma in this. And before we learn how to read and write data in CSV file, you should know the two basic functionalities, get WD and set WD functions in R. Get WD function will help you to understand or will help you to know on which directory currently the R workspace is pointing to. And set work directory, that is set WD function, will help you to set the path where you want all your files to be stored, where you all your files to be retrieved. That path can be set using set WD function. We will be looking at a demo for all these. And then once our working directory is set, once you know your working directory path, then you can go ahead and read the content from the CSV file using read.csv function. And if I want to store some data inside my CSV file, I can use write.csv function. Now let us see how to do these practically in our environment. I hope today the font size is big enough for the people, especially who are watching from YouTube. Yesterday, only after the session, I got to know the letters were not so clear. I'm really sorry about it. But now, today, I have I have improved the size of the font, increased the size. Hope it should be visible to you in the YouTube window as well. Now, How to get to know the working space, the path of my workspace, you should use getWD function. So at present, it is basically it is pointing to documents. I don't want my workspace here. I would like to set it to E drive. So how should I set it? Set WD E drive. After setting this, when you go back and check what is your working directory now it is E drive. Now, after setting your work drive, now this is the point very important. Read.csv off. Mention the name of your file. Uh, at present, the file is located in my workspace, that is E drive. There is a file called file1.csv. Read the content of the file and store it in data. When it reads the data from a file, it will read the data in data frame format. Now, let me execute this line number 6. Yeah. So now my file content has been read, and now I'm checking. So the data that is read has been stored in data. You are checking, is it a data frame? Yes, that's why you are getting the Boolean result as true. And now if I want to know the number of columns in that file, you can use ncol of data. So there are 5 columns in my file and number of rows is 8. There are 8 records, 8 rows and 5 columns in this Excel sheet. This is how you will get to know the structure of the file. Now, before that, I would like to show you, yeah, 1 minute. So for your understanding, this is what I have. This is what I have in my Excel sheet. I have 8 records and these are the columns: ID, name, salary, start date and department. These are the columns I have and I have 8 records in it. I just read this particular data just now in my OR environment. Now, after reading data, how to fetch, uh, depending on certain condition. See, when you look at this statement, in my data frame data, you just pick up the column called salary and it has some numeric data in it. Find out the maximum value of the salary and store it in a variable called sal and print the same. So you are accessing a specific portion of your file. So the maximum salary is 843.25. And now, when you look at the next line, I'm trying to fetch the details about a person who is getting the maximum salary. So how can I retrieve specific records from my file or from my data frame? So you need to use a function called a subset and retrieve data from where? From the data frame data. And am I going to retrieve everything? No. Whichever record is having the salary equal to the maximum salary, retrieve that alone and store it in this and print the same. When you do that, I'm sorry. Yeah. So record number 5 is getting the maximum salary. A person called Gary is getting the highest salary. And now there is one more example. I'm trying to fetch the details of all the employees who belongs to IT department. Now when I print it, so there are 3 records coming under the department IT. So you can provide some condition, not only equal to, you can get greater than, less than, all the comparison operators can be used. You can filter and retrieve that specific data alone from your data frame. And this is all about reading data from the existing file. Now, if I want to write some data in CSV file, then what I should do? Now, this is for our understanding. Now, when you look at this code, I am extracting a specific, I'm just extracting a portion of records from my data frame. What is the record I'm extracting? The employees whose start date is greater than 1/1/2014. It means whoever have joined after January to 2014, those records will be retrieved and it will be stored in retrieval. And if you want to know what are those records, let me quickly print it and show that to you. Yeah, there are four records satisfying this condition: 3, 4, 5, and 8. Now what am I going to do? What I'm going to do now is I'm going to store those four records alone in another file called outfile.csv. How should I do that? Write.csv of what is the data to be stored, the four records found in retrieval, and store it in which file? Outfile.csv. And then, so write it, and later I'm opening the same file and I'm reading it, storing it in another data frame called new data, and I'm printing the same. When I print this new data, the same four records you can see. This is how you will read and write data in CSV file. Yeah. Now let us move on to the next type of files. Now, next we are going to discuss how to work with Excel file. Microsoft Excel is the most widely used spreadsheet program which stores data either in .xls format or in .xlsx format. You can read data directly from these files using some Excel specific packages. See, when you look, for accessing the data from CSV file, we didn't import any specific package or library. But in order to work with Excel, we need to install packages, right? The few packages to work with Excel are Excel Connect, Excel SX, Gdata, and so many, a few other packages are also available. I'll repeat. To work with CSV, I need not have to install any specific packages. But in order to work with Excel file, to read and write data in Excel file, we have to install special packages in our R environment. Then what are those packages? They are Excel Connect, Excel SX, Gdata, and few other things are also available. The entire list is not provided here. And using these packages, you can very well read and write data in Excel file. Now let us see a demo for working with Excel file. Let me go back to my RStudio. For now, I'm just going to clear this off. To work with Excel file, I have installed a package called Open Excel SX. Right? Excel SX is different. This one is different. People usually use Excel SX only. Uh, Excel SX is depending. It's dependent on Java and its version everything. But Open Excel SX is not dependent on Java. So I am using this. So first you must have installed this package as a step one, and after that the next statement. It is just like importing a library. So library of Open Excel SX. It is just you are importing that package to your R environment. And after that, in my system, in my E drive, there is a file called file2.xlsx. I'm just reading it. How? It is read.xlsx. Even this read function will also retrieve data in the form of data frames, and I'm storing it in a frame called data new underscore data. Now let me read it, and then later I'm printing it. This is what I have. This is the tabular data I have in my file called file2.xlsx. So this is a simple read operation. Now, how to write data inside a file? Now, yeah, let me change the name as file 3. I have all my data stored in my data frame. The name of my data frame is stud.data. I have name, mark, department stored in it. And I don't want the string values to be interpreted as factors. That's the reason I have disabled it. I have set it as false. I don't want that to be considered as factors. Do you remember yesterday we discussed factors? Factors will fetch all the unique values from the respective column, and those will be set as levels, and all the unique values will be given some levels. So those things I don't want to happen in my the string data that I'm using here. That's why I have set it as false. Now my data frame is ready. Now I'm going to store the data in my data frame inside my file. How should I do this? I can do that by using the function write.xlsx. What is the data to be stored? The data that is found in that has been stored inside my data frame stud.data, comma. I should store it in a file called file3.xlsx, and I want the column name and the row names should be added to my file. And in which file I should, yeah, you can do it previously. Either you can open an existing file and you can mention it is sheet 1, or existing file and you can mention a different sheet. Let me do the same, or else you can write it in a fresh new file also. Let me do it in the same file in the second sheet. Now not found, yeah, I didn't execute this. So now my data frame has been created. Now I'm trying to write this data inside my file. Now you just read the data and print the same. 1 minute. I will show you the Excel sheet now. File 2. So now when you do it with the existing file, what's happening? Uh, the entire thing is getting replaced. Whatever the old data, that will be replaced. And this is what the same data has been stored in my file 2 in sheet 2, and the same is getting retrieved in my R environment. This is how you will perform a simple write operation in Excel sheet. Now, moving on to the next. uh, JSON format, a JavaScript object notation. So you should be knowing this file format as well. So this is the most widely used file format in storing data and to transfer data between one application to another application, especially in API and web services. The JSON file format is widely used. So now R is giving us a provision to read data from a JSON file also. If I want to read data from JSON file, I should install this package called rjson. And then after installing it, I can make use of the functions in it. So when you look at this, I am retrieving data from a JSON file called employeeinfo.json. This is how I need to mention the file name. And the function I'm using is from JSON. Retrieve it and store it in a variable result, and later you are printing it. Now let's see a quick demo for this as well. So we need to ensure we have installed this package called rjson. Once this is done, I need to import this library, and then I can make use of the functionality from JSON file. This is the JSON file. Retrieve it and store it in this one. And it is unlike the other read function. JSON will read the data in text format, and I'm storing the same in my result. And then later, if you want to convert the text format into data frame, I can do it using as.data.frame, convert the JSON data available in result and store it in a data frame, and then later print the content. Yeah. no worries on that. Anyway, however, my data got retrieved and the same has been stored in my data frame. So this is how you will read data from JSON file format. Now, the next important thing that we are going to discuss is how to retrieve data from database. That is also another one. Uh, Not necessarily always you will have your data only in files. Sometimes I will have my data stored in databases as well. So R has functionalities which will help us to retrieve data from relational databases like MySQL, Oracle, SQL Server, etc. And you can fetch records from those databases and you can store it in data frame, and from there you can further manipulate, you can analyze your data by applying the statistical functions. Once the data is available to our environment, it becomes a normal R data set only, and it can be manipulated or analyzed based on the previous other functions we discussed. And from there you can build data model, you can clean the data, you can transform the data, you can do everything once the data is made available to the R environment from your relational database. Now I have MySQL installed on my machine. I'm going to show you a demo on how to retrieve data from MySQL. Now, what is the package or library I need in order to work with MySQL? So, to work with MySQL, in order to interact with MySQL databases, we should install this package called RMySQL. Ensure you have this package installed first and then import this package saying library of RMySQL. Once this is done, establish the connection to your database. How? Using DB Connect and then MySQL function. And you need to mention the credentials to access your database. And your database will have several DB in it. You just need to mention the data DB name and mention the host. It is local host. Establish connection to your MySQL. Once this is done, I can list down all the tables available in the database I have mentioned. How? If I want to know the list of tables available in my database I have mentioned. What is the database I have connected to? The database called world. So this command will list down all the tables available in the world database, all the tables available in world database. There are three tables, namely city, country, and country language. Now I got to know, I got connected to my database. Now I got to know the list of tables in my database. Now I'm going to start interacting with my tables. I'm going to fetch records by writing the query, by sending my query command to the MySQL database. How? For that, we need to use this function called db send query. And this query will be executed with the help of the connection object MySQL connection. And what is the query I would like to execute? Select all the records from country. And I have even mentioned, yeah, for now, let me do, let me try to fetch all the records. It means all the columns will be retrieved and all the records, rows will also be retrieved, and it will be stored in my result. And then the records in the database format, table format, I'm converting that into data frame. How? Data.frame equal to fetch of. Fetch the records from where? From your variable result. Am I retrieving all the records? There are hundreds of records in this table, but I don't want everything. I just want to retrieve only the 10 records, the first 10 records. N means number of records you like to fetch. Uh, the only those many number of records will be fetched and that will be populated here. And let me do that. Let me execute my query, and then it has been stored in my data.frame, and the same it is getting printed. And when you look at the columns, only top 10 records have been uh, fetched, and there are so many columns, namely name, continent, region, surface area, and there are so many columns. That's why it is getting wrapped and it is getting displayed. These are the so many columns. And when you look at my next query, for example, I don't want all the columns to be retrieved. I just want only the few columns: name, continent, region, retrieving selected columns from your table. And I can do the filtration also. I just want only the continent Asia to be printed. Huh. Hang on. So let me do from the beginning. I'm sorry. So now it is not fetching all the columns. It is fetching only the three columns data: name, continent, and region. Not only this, any SQL query, you can execute it. You can do apply where class and filter your data. You can apply aggregate functions and get the required data. And then you can even update your data in your database through writing update queries from our environment. All these are possible. So in order to work and interact with our database, I mean MySQL database, this is the package you need. And similarly, this package will vary from one relational database to another relational database. Now, that's pretty much on file handling and interacting with databases. The next we are going to discuss is on the topic data visualization. What is data visualization? What generally in our environment, you will deal with huge amount of data. You will clean it, you will transform it, and you will do lot of analysis, and you will come up with so many data models out of it. In order to communicate your analysis results, it has to be visually presented. When you present any data visually, it will be more comprehensive. The another person listening to it will be able to understand it in a better way. And now, if I want to present some data in a graphical format or through chart in our environment, what are the packages available? What are the libraries I have in order to work, uh, in order to present data visually? There are so many things. I have listed all these: plot, ly, ggplot, tidyquant, touch charts. All these packages are available. Now let us see how to make use of these packages and how to plot various charts and graphs. First, let us discuss how to plot uh, pie chart. Pie charts are created with the help of a function called pie function, which will take vectors as input. Based on the data you provided, it will design, it will come up with a pie chart automatically. So pie function has several parameters we can give. You can mention the labels for your chart, you can set the colors, you can give titles, and you can set the legends also, using the various parameters available in pie function. Now let us see how to create pie chart in our environment. Want that pie chart to be stored as an image file in your working directory, then you can use this PNG function. The pie chart that is going to be created will be stored as an image file in your working directory. So how can I achieve that? Say PNG file equal to, mention the name of your file, and then plot your chart. How? By using the function pie. And what is the data to be plotted? The vector name, that is x. And then what is the label to be used in the pie chart? Whatever the data that is enclosed in the labels vector. Now let us see. here. Now the pie chart has been stored inside your file, the working directory. Now let us visit the working directory and see whether this file has been created or not. One minute. Okay, there is an error. One minute. Let me quickly execute this. Yeah. When you go back and see, in your working directory, there is an image file created called country. When you double click that and view, you will see that pie chart created. This is the pie chart created through my R environment. The whatever the labels you have given is mentioned accordingly. The vector data and the label has been mapped accordingly, and the same is getting plotted here as pie chart. Now, let us see what do we have next. I'm trying to plot another pie chart. This is the data for it and the labels I have set. And I'm giving a different file name. Here I have introduced something called, I am giving some title for my chart, and also I'm setting the colors. Earlier the color was default color, so it was light. And if I want to come up with different dark colors, you can make use of this function called rainbow. And rainbow will take the parameter, a number will be given as a parameter to rainbow. It will basically take the number of colors you would like to have. Here I'm just saying length of x, so it depends on the number of items in my vector. If my vector has 4 elements, then 4 color will be created. uh, that is the significance of this rainbow of length of x. Now I have my vector ready, the labels created, the file name also I have mentioned. Now I'm plotting the pie graph according to the specification given, and then it is done. So unfortunately it is not showing up here. So usually the plots, I mean the charts that you're plotting, you can view it in this plot window. It will be visible here. If not, let's go back and look at that in our working directory. So let me go back to my working directory. I can see something called city title colors. I'm just opening it. And this is the colorful pie chart created using the second instruction. I'm using the rainbow colors, and I have instructed 5 colors to be used, and the same is getting printed. And for the entire pie chart, a common title has been given, city pie chart. Now, and then so this is on adding percentage to the data that you're uh, plotting. Now I have this data ready. This is my vector data and the label set. And now I'm calculating the percentage. So each and every value, I'm finding out the sum. This is basically the formula to what? Calculate the percentage. And once it is round off function you are using, if it has some decimal point, there are so many digits after the decimal point, you are rounding that off in such a way that there will be one number after the decimal point. So calculate the percentage, round off to one number after the decimal point and store it here. And then I want this file to be stored. So I'm mentioning the name of my file, and then I'm plotting the pie chart. Please listen. Pie of, this is the vector data to be plotted, and you're giving the labels pie percent, and then your title for your main chart, and the column I want the rainbow colors, and then you're adding the legend also. Where do you want the legend to be positioned? On your top right. And what are the various legend to be mentioned? the cities, the basically the labels, and then fill the rainbow colors. The fill color also you are mentioning. So plot the graph, pie chart, and then say only calling this div off, the file will be stored permanently. The image will be stored as file. Now I'm just going back to my work directory. A new image file got created, city percentage legends. When I open that, I will get this one or not. Yeah, you can see the percentage also. Where is legend not coming? 1 minute. 1 minute. Yeah. So when you see the pie chart created now, this is how it will look like. So all the percentages added, and also the legend is also added on the top right side. By using various values for that, you can position it in different location as well. This is how you will add legends to your pie chart. Now the next one, how to create 3D pie chart. So if you want to add 3D pie chart, if you want to plot 3D format, I need to install another package called Plotrix, and you need to import the same library. And let me quickly do that. Run. So it's all done. Label has been created. Now, this is the function to create a 3D pie. Earlier I was just using pie. Now it is pie 3D. The vector data, the labels are available in LBL, and what is the title you would like to give? Okay, it's too large, it says. Okay. Okay, it is not showing up here. Let me remove this line so that I can have this stored in my system. Yeah. Now let's go back to the working directory. One minute. So unfortunately, it is not opening, but this is the code snippet is perfectly correct. You can follow this. Uh, where did our studio go? Yeah. So you can follow the same code snippet. Definitely that will work. And the next one is on bar chart. If I want to prepare a bar chart, I need to make use of the function called bar plot. And you can adjust your parameters so that you can be plotted vertically and also horizontally. And then you can even draw histograms also. If I want to plot histograms, I need to make use of the function hist function. And If I want to work with line chart, I need to use the function plot of. So now let us quickly see the demo for all these four. So this is on a pie chart just now we finished discussing. Now let us move on to how to plot bar graph in our R environment. I can draw a bar chart by using a function called a bar plot. Even this will also take vectors as input. Okay, now I have my data ready in a vector, and then I have my labels also, and then I want this bar chart to be stored in my file, and then the function bar plot of what is the vector data h, and the labels are found in the vector m, and what is the label for x-axis, label for y-axis, and how do you want the bar graph, the color of the bars should be in blue, and the name of the title of the bar chart is revenue chart, and I want the bars border should be in red color. You can specify the colors as well, and then ensure it has been saved. And now this is how your bar chart will look like. For the data I have given, month wise, according to the number I specified in the vector, the bar graph has been plotted. The X label, Y label, and the main title, everything has been added. And the color of the bar is blue and the border is red. Based on my specification, the bar graph has been plotted. This is how you will work with bar graph. And also, I would like to tell you one more thing. Whatever we are looking at is what basic and the commonly used parameters. But if you take bar plot, there are many other uh, parameters are also available that will help us to format our chart accordingly. If you want to know uh, in detail about any functions available, any command available in R, always we can use this help of. You just whatever you want to know, you can mention it. I just want to know about bar plot function. So mention it. And when you execute it, the details about the bar plot will be displayed in your help window here on your right side. So you can get to know what is bar plot all about, what are the various arguments of the bar plot. You can set the height, you can set the legend text. There are so many parameters, so everything cannot be discussed in the small scope, but this one will help you to explore, and you can have your hands dirty by making use of all these functions, and you can explore and get to know all these things. But anything that you want to know, we can make use of the help function. This is on bar plot. I have one more example for bar plot. Let us quickly see what is new in that. Now it is not going to deal with one data. My bar plot now, it is bar chart is going to deal with uh, multiple datas. So I have three vectors created. One is the color, the next one is month, and also one more thing is added, region is also added. Now I'm going to have all these values. See here, there is a matrix. These are the data, and I mentioned all of us are familiar with creating a matrix, right? Number of rows and number of columns you are mentioning, and then the name of my matrix is values. Now I want this bar chart to be stored in my file. Matrix created, file created, and I'm plotting my bar graph, the value and title, and the parameters are months, and what is the x-axis label and y-axis label, and the colors. What are the colors you want? The colors you are mentioning. And now my bar plot is ready. And then you are adding the legend also. The legend says top left, not on the right. Now you are adding it to top left. And the what is to be mentioned, the regions is going to be the legend, and cex is character expansion. It will determine the size of the legend box. If it is 1.3, it will be less. If you make it as 3 or 4, the character expansion, the letters will be little big and the space occupied by the legend box will be more. And you're adding fill colors also. You want only the outline or the colors to be filled, you can mention that as well. And then now my bar plot is ready and it got saved in my file as well. Now let me go and bring it up. This is how a bar plot will look like. So you are bringing everything. You are mentioning for each and everything what is the east data, west data, north data. So you are working with multiple things. These kind of bar plots can also be plotted using R. And now you can explore the other things as well. Let me show you one thing that is important. Histogram is something similar to bar plot, but it is little different from bar. You can explore it on your own. Let me show you the coding for line chart. How to create line graph in our environment. Now, this is the data for my line chart. And I want this line chart to be stored in my file. And then to draw a line chart, I should make use of the function called plot. And what is the data to be plotted? Found in the vector v. And the type is L. L means I want the line to be plotted. And it takes other parameter also. I will show you one by one. And when I say L, only line will be plotted. When I say O, only instead of the respective points will be plotted using the points. Only you will see the point. Sorry, only the points. If you want, you can see use P. And I want both line and points to be plotted. You can say O. It's O. I will show you the difference when I'm showing you the line graph. And what is the color you would like to have? And what is the label for x-axis and y-axis? Mention it. Your line graph is ready and the same got stored on my system. Now let us see how a line graph will look like. This is how your line graph will look like. So can you see a line is also visible and you should be able to see the points also. Can you see the points? This point is also plotted. It is because of the parameter I have mentioned it as O. When you say L, you won't be seeing any of these points. Only line alone will be visible. And when you say P, only the points will be plotted. I want both the lines and points to be plotted. Then you can say the parameter as P. Sorry, O. And then moving on to the next one. Can I draw multiple line graphs as a part of same? Yes, I can do that as well. If I'm dealing with multiple data, you can have that also plotted, multiple line graphs. For that, see, I have three vectors, v, w, and x. There are three data I'm dealing with. And I want this to be stored in the name multi-line graph. And this is very important. Plot will plot a line chart first. First I'm plotting V first, and I want both line and also points to be plotted, and the color is green, and the label for x-axis and y-axis. This is the initial line graph that is going to be plotted. On the existing line graph, I want to add a couple of other lines as well. You want to add more lines to the existing line graph, then I should use this function called lines, right? Lines, line graph for vector w and line graph for vector x. And for vector x, the line will be red, And for, sorry, W, it is red, and X, it is going to be blue. So have all these line chart ready, and this should be available in my file working directory. When you look at it, this is how multi-line graph will look like. So the line graph for three, one in blue, another one in red, another one in what? Green. So this is how you will plot line graph in our environment. Now that's pretty much uh, the topic that I have planned for today. But still, however, I have a couple of things to discuss with you on the previous topics we discussed. One is on uh, reading data from the user. Now, so earlier we used a read line to read the data from the user. Runtime, if I want to get some data from the user, we use read line. But there is a limitation with read line. Read line will work only in our interactive mode. If I execute my program in the script mode, the read line will not work. Now, if you want to read data from the user in the script mode, then I should go for using this scan function. Scan, read data from standard input device, and then convert that into numeric. And how many inputs it is to, and store it in the result variable and print the same. Now have this file saved, and I'll call it as inp.r, and then go to your terminal. Yeah. So execute it in the batch mode. R script filename.r. So it will read two items from you, and the same will be printed. I'll repeat. In our first session, we saw a function called readline to read data from the user, but that will work only in the interactive mode. If I want to read data in the script mode, then I can make use of this scan function. And coming on to the data types, apart from the 5 basic data types, we discussed there is one thing called raw data type is available. Raw data, but we didn't see any demo for it. The raw data is all about storing whatever the data you are storing, that will be presented inside your system in the hexadecimal format. Now let's quickly look at that as well. See, this is the data I'm dealing with, learning art programming. You are converting that into raw data type, and you're storing it in a variable, and then you are printing it. Now, so far, we dealt with, if I want to display something, so far we were using only print. Printing job can also be done through this function called cat. Now, when you look at it, the actual original data is learning R programming. But when you turn that into raw, each and every characters in your data will be converted into hexadecimal format. So this one will help you to add your text plus, and if you look at the display, the what is the class name, what is the type it is a raw type. This is how you will work with raw data type. And one more thing, in the beginning of the session, one of you asked me to revisit the data frame. I'll quickly bring it up. Yeah, 1 minute. Now, the one who asked me for the data frame will help you to store data in this fashion, in row and column format. And the data that you are storing, the data in a column, if you take, in a column wise, all the data will be of same data type. But in row wise, if you take, everything will be what? It will be in different data types. If you want to deal with data in tabular format and the data will be of various data types, you can go for data frame. I don't want the string data to be interpreted as factors, then you will set it as what? False. This is how you will create data frame and printing the content of data frame, and then selecting only the specific column and you're putting it in final, and then you are printing the same. And how to extract one specific row, you will mention the row number. I just want to print only the row number, respective row. And I want to mention a set of rows to be retrieved. I can mention it as from 4 to 5 rows. Four, it means basically fourth and fifth row will be retrieved, and the same is getting printed. And how to add a new row to your data frame, I can say create a list and then add it to your data frame saying r bind of the respective, in which data frame you would like to add emp data, and what is to be added, the list called x to be added. Similarly, a column can also be added to your data frame using cbind function. And yesterday one of you asked me why when I'm deleting it, why is it always starting with 1? It is not nothing to do with 1. When I say -1, read the first, I mean, delete the first record from my data frame. If I want to delete the fifth record, I will say -5. It depends on the row that you would like to what? Delete. That is that is with this minus. Negative means take that off. Delete. That's it. If you want to delete a specific column, choose that column name and you set it as null. By setting null, the respective column will be removed from the data frame. These are the basic operation you can do with data frame. That's about it from my side. I am done for today. I'm stopped sharing my screen. Over to you, Mr. Vishwanathan.
Okay, ma'am. Dear participants, do you have any questions? Please post it to your chat box. Ma'am, ma'am, shall we wind up the session, ma'am?
Yes.
Okay, thank you, ma'am. It's a wonderful session. Thank you, ma'am. Honorable Principal Dr. K. Ravindra Garu and all the participants, it's my privilege to deliver a vote of thanks on this wonderful occasion. First, I would like to thank our speaker, Ms. V. Geeta, Learning and Development Manager, Software Engineer, Tulip IT Networks India Private Limited, Chennai. Thank you, ma'am. Thank you once again for allocating your valuable time in sharing your experience with us and enlightening us. This workshop couldn't have been successful without our dynamic principal, sir, Dr. K. Ravindra Garu. Thank you very much, sir. I would like to express my gratitude to CSE HOD, Professor SMD Mujib, for his constant support and his valuable suggestions in organizing this workshop and made it as grand success. I would like to thank these workshop coordinators, Ms. Anuradha Reddy, Assistant Professor, and Ms. Rajkumar, Assistant Professor in CSE Department, for their cooperation for organizing this workshop. And our technical advisor, Mr. R. Naveen, for his unconditional support. Thank you, sir. And finally, I would like to extend my thanks to all the participants for their active participation and making this workshop a grand success. Thank you all once again. Thank you.
Thank you, everyone.
Dear participants, we have shared the feedback link into the Zoom chat box and as well as YouTube chat box. Please fill it appropriately. After that, you can get the certificate. Thank you.